Regression notes, we got a piece of paper. It's a miracle. I like to do a question or two before we do the definition. So we're going to skip some of the stuff up at the top. We're going to go here. Our goal is to look at these stats and come up with the regression line or the line of best fit. In fact, in IB, because it's international and because it's British, they call it the goodness of fit, which is so not American and silly sounding, but let's get into it. So we want to get these stats into our calculator. Let me see if I can turn the volume down a bit so you can see it a little bit better. I can't turn it down anymore. Maybe I can turn down the exposure a bit. Okay. Stat, edit. Oh, I've already got them in. Excellent. I'm the best. Make sure you got them in exactly. Mine are a bit wrong. Probably for some examples later down the thing. Okay, once we've got them in, we know that we can do stat. We can do stat calculate. We know about one variable statistic. We even know about the frequency lists. And we don't have frequency for this question, but this is one variable stats, which would find our average for just the X column. We can also do stat calculate number 2, which is the 2 variable statistics. And this will think about the first list as the X's and the second list as the Y's. And it's not super useful, but it does tell you the X average and the Y average, so that you don't have to do like 2 different 1 variable statistics if you want to do a 2 variable statistic. But what we want to do today is calculate the regression. Okay, so first let's go ahead and plot these down. We've got 1 through 5 on the bottom and 2 through 10 on the left. So 1, 2 would be 1, 2, and then 2, 4, 3, 6, 4, 8, 5, 10. I think that looks pretty solid. First question, how can we get our calculator to graph these dots? Does anybody know? If we put them in this calculator, you know, they're in there, how can the graphing calculator graph the coordinates? You doing all right, Jack?
Yes, all right.
I got you. So the good news is sometimes in math and sometimes on the calculator you have to go a long way and the names are really bad, but right in the top left of your calculator, oh, I just cannot see it. There we go. There is the stat plot, which is perfect. That's what we want to do. We want to stat plot or plot the stats. So we have to press second because it's a blue word. So second y equals. And then we'll be looking at this display. We have plot 1, plot 2, and likely it will say off, 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 off. And so we need to turn these on. So just press enter on the first one. And you can see that it's turned off, and we can turn it on by pressing enter again. You can see that it's using the X list as L1 and the Y list as L2. That probably 99% of the time is going to be something we don't have to mess with, but if we needed to, we could go and change it there. You can even change the different looks here. Check this out, box and whisker plot, right? We've got a nice histogram. We've got all kinds of stuff here. But the very first one is just a scatter plot. And now if we hit the graph button, we can see our data plotted on the graph. Now this is okay and definitely getting better, but it doesn't really look much like our paper because we have all of this wasted space in quadrants 2, 3, and 4. How can we zoom in on just our plots? If you had to bet $1 million on it, probably the button that says zoom. So if you press zoom and go in here, and if you had to bet $1 million on it, where are we going to find zooming in on our stats? number 9, which says zoom stat. And so if you press zoom stat, it will then zoom in precisely onto your stats. Now this is normally pretty good. Sometimes you might want to look at your stats and this will zoom in so much that you're like, God, I wish I just had a little bit more room. And we'll talk about how to adjust it. But for the most part, you need to know how to get these stats in. Everybody knows that. How to graph these stats, which is second y equals, make sure it's turned on. And then how to view them, which is zoom 9 to zoom in on them. Now, just to make sure that we are comfortable with the calculator, I don't want to look at this zoom for the rest of my life. So how can I go back to just the standard zoom if I'm finished with this plot? What number do we like for that? Zoom 6. So some students will be in the habit of doing 2nd plus 712 to reset their whole calculator every time. But that becomes a bit of a problem for us because then we'd have to go and turn the plot on again, and that's annoying. And there are some other things we're gonna see that are also gonna be annoying. So now that we're here, zoom 9. Now I wanna actually calculate my line of best fit. Now your line of best fit is something you should have heard about in Algebra 1 and Algebra 2. It is the line that will do its best job to approximate all of these data points. It's not guaranteed to go right through all the data points, but it should be pretty solid. We're gonna do that by going over to the Calculate tab, scrolling down to number 4, or just pressing the 4 button, and it says Lin Reg, which is the linear regression. Click on linear regression, and we can see a lot of things here. We can see use list 1, use list 2, and then if we hit calculate, it will calculate our linear regression for us. And yours should look a little bit different. Does yours look different than mine? Okay, what do I have that you don't have? R squared and R, of course. So we'll talk about why my calculator is a bit leveled up in just a second. What is important is that the A and B values are the coefficients for the y equals ax plus b. And so let's go ahead and over here, it says regression line. Let's go ahead and set that up. That would be y equals 2x plus 0. Of course, you don't have to write plus 0, but may as well. Okay, now we want to graph it. Now for this one, it's super easy to graph. It's a linear graph. It's got no decimals, no fractions. Start at 0, use a slope of 2. How can we get the calculator to graph this line? Well, we have our stats here. We could then go into the calculator and press y equals, and then press 2x plus 0. You don't have to press a 0. And then graph it. And now it will graph it for us. And honestly, that's not very difficult, but it could be difficult, right? What if we had 1,000,000 decimals, right? What if we had something really crazy and, are we supposed to round? How much is that gonna affect our data? Because with stats, we wanna be really careful. And so there's an easier way to do that. If we go back to y equals and we clear it out, and then we go to stat, calculate, 4. Down here, it says store regression equation. In other words, the calculator is asking you, what do you want me to do with this? Do you want me to put it into the calculator somewhere? And where we want to put it is in y equals. Now, how can we get y1 to be there where it says store regression equation? We got to find it somewhere in the calculator. We should be able to find every single button in the calculator in the catalog, which is on 0, where it says catalog there. So if we press second 0, that will pull up the catalog of every single button alphabetically. And we're looking for Y, so you can even press these letters to skip around the alphabet. So if I see the 1 here, which has the Y on it, I can press the 1, And that will take me down to the y things. But unfortunately, there's nothing in the calculator that has that y on it. So we are, what's the point of this, right? Second, calculate number 4. We can find it in alpha trace. So we are very comfortable with alpha y equals, which is where we find our fractions and square roots and things like that. But all of these alphas are really nice, and they allow us to kind of like make our calculator much better. Well, alpha trace brings up these y1s and y2s. And so then if we press y1, now it will say to store my equation in y1. That way when we calculate it, it'll show it to us, but also it will automatically put it into y1. Again, that might seem like you don't need to do it, but we're gonna be doing questions with a lot of decimals very soon, and you're gonna want that to happen automatically. Awesome. We can go ahead and graph our line. You probably already did this. Mine's a little bit scuffed because I missed my dot, but you get it. Now you've been looking at my piece of paper my calculator, and my calculator has been saying that the r equals 1. And so maybe you've already written r equals 1. But how come your calculator doesn't say that? The truth is, I don't know why it doesn't say that, but by default, it's not going to tell you about the r or the r squared. And this is something that, again, your IB students, juniors and seniors, this is a weird thing. We need to find this in the catalog. So we're gonna go into our second 0, where there's all the different things in our calculator. And this is called the diagnostic. So you can either scroll down a million times, or you can find the D on the calculator, which is this little matrix button, this little X inverse button. Press D, and then it'll show me, so I'm going to keep going back and forth with the exposure. The day of week, there it is, diagnostic. By default, the diagnostic is off, which is just annoying, but it is. And so we're just gonna do diagnostic on, enter, and now, whenever you do your calculate, it will come back. Stat, calculate, 4, enter, 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 enter. You should have your r and your r squared. Now, anytime that you are losing, your RAM, anytime your batteries get knocked out, anytime your calculator dies, anytime you do second plus 7, 1, 2. Now, if we go back, our stats are gonna be empty. Also, our diagnostic is gonna be turned off. Whoa, this thing is just going crazy. All right, now let's speed it up a little bit because we've been talking about this forever. At this point, we pretty much get it. This correlation coefficient is your R, and the correlation coefficient is basically how correlated is this data, how nicely does it fit onto a line. The R goes from -1 to +1. So you can see here we have a scale. -1 is a perfect negative correlation. All the way up until 1, which is a perfect positive. Now, if you are doing data, I'm sure you will, you're going to take a science class in college or somewhere, or in your IB physics class, they're going to have very high standards for this R. You need to have an R that is greater than 0.95, which is a pretty typical standard. If your R is not around the 0.9, it's just not correlated enough. The calculator is trying hard to make it work, but it's trying too hard. So in here, we're gonna call this strong if it's somewhere above negative 0.75, but again, you'll see pretty soon that we're gonna get more and more picky, and it's not really gonna be considered strong unless it's like 0.95, but I guess by definition we can call this strong. And then we'll have moderate, and then we'll have weak. And then it'll work its way up with weak, moderate, and strong. In the middle, if you are anywhere near zero, it's basically things that just have absolutely no correlation on each other whatsoever. So this would just be like no correlation. Again, if you are in a science class, they might even tell you that like a 0.5 is a no correlation because it's just a pretty weak amount of correlation. So if we have a 1 for our value, we could say that this is a nice perfect positive correlation. And the last thing is to extrapolate. And so this is technically called modeling because we are modeling the data and modeling it with lines. And this is one of the best careers if you're trying to just make a lot of money, okay? Basically what we're trying to do is use some data that we have to predict data that we don't have, which means we're kind of using math to see the future. And people who don't like math are very scared of that. In reality, it's really not all that scary. And people, businesses, desperately want to know what's going to happen in the future. And so we have two words here, extrapolate or extrapolation and interpolate or interpolation. These are essentially the same things. These are ways to go and make guesses and go and make evaluations at different X values. But extrapolation happens outside the data set, whereas interpolation happens inside the data set. So this would be considered an extrapolation because 16 is much, much bigger. Of course, you guys are probably able to put two and two together that the farther away we get from our data, the less accurate it will probably be, especially if we have a weak coefficient, but this is a 1, and so it should be pretty easy. We might even be able to calculate this in our head because we have such an easy graph here. Does anybody know what the value extrapolate that we could kind of assume X would be, or the Y value would be when X is 16? 32. Yeah, 32. And again, that's really easy to do in our head because it's 2x plus 0 and the x is 16. So it's just 2 times 16 makes 32. All right, let's move on and we'll do this one really fast. And I'm as always, talking. This one, it's the same thing except for it's backwards. It's going 10, 8, 6, 4, 2 instead of 2, 4, 6, 8, 10. So it should be very similar. 1, 10, 2, 8, 4, 3, 6, 4, 5, 2. Stat edit. 1, 2, 3, 4, 5. Make sure your stats is on. You can zoom 9. Looks pretty good. There it is, looks pretty good. I can even calculate the lin reg. I can even ask it to store the regression into Y1. This time I'm getting, this is so, Y equals negative 2x plus 12. I reset my computer, my calculator, of course, annoyingly, so I gotta go turn my diagnostic on. This time I got my R was -1 because this has a negative slope, of course. If I look at my graph, there it is. If I look at my graph, it's a perfect negative correlation. It's going down. Now this one's not quite as easy to calculate. It actually is still rather easy, but to calculate x equals 6. What can we do? What's the easiest way to figure this out? I've done a lot of calculating this in my day, and I think that I have like a little bit of a secret strategy for finding these x values. Again, it's not very tough right now because they're integers. They're all pretty easy. But how can we have like a foolproof way for the calculator just to tell us what we want, okay? I think that the best way to do this is you can go ahead and do second window. And when you do second window, it's gonna pull up your table setup, and at the very first thing there, it's gonna tell you the table start. Your table obviously is going to show you the x values and the corresponding y values. And so if you just ask it whatever number you want, like 6, then when you do second graph to pull up the table, it will just take you right to 6, exactly where you want. Now again, this is pretty easy. You could have done this in your head and figured out it was 0. But even if you wanted to, let's just say, calculate it when it was 5.235, second table, it will tell you exactly what that value is. It'll take you right there, and it's a guaranteed to work every single time. So I think that that is a very good strategy. Maybe we'll use that more going forward. So y equals 0. Okay, let's flip over to the back. We're doing pretty well, okay? I think that we get the idea. Let's do one of the top two and the bottom one. I think we're overdoing this a bit. Edit. Now, again, trying to help you guys out with more calculator tricks. How have you guys been clearing out your lists? What's the best strategy for clearing the lists of data? So, you could go delete, and do that, but maybe we have a whole bunch of data. And so the best way to do it is to scroll up to the L1 and then press clear to clear the L1. And then you can press either down or enter, and it will just wipe the whole table for you. Now you want to be careful, because if I go up and I hit delete, and I delete L1, I have basically just like doomed my calculator. L1 is gone. I don't know how to get it back. I remember years ago, my teacher had no idea how to get it back. I went to college. Nobody knows how to get that L1 back. And of course, all of your stats are gonna be debriefed or like automatically going to L1. And it would be so annoying if you had to change that to L2 every time. So if you edit, delete one of your lists, you made a big mistake, and you're just gonna have to second plus 712, reset the whole calculator, which isn't that big of a deal, except for second, catalog, D for diagnostics, scroll down, turn your diagnostics on. Second, y equals stat plot, enter, turn your stats on. And you just have all these like upkeeps that are pretty annoying. So let's see, did we do the top one? Did anybody get a R value for the top graph? Anybody get one? Again, hopefully you're taking advantage of storing it in your Y1. Did we get this for our R value, 0.979? I feel like maybe I'm going too slow. Am I going too fast actually? Or are we doing okay? Okay. I've got my regression line, y equals 2.1, x minus 0.3. And I've got my r value, 0.979, or maybe 0.98. Is this good correlation? Is it strong, moderate? How would you describe this 0.97? This is strong, and of course positive because it's a positive number. I didn't graph mine yet. Let me go quickly. 1, 2, 2, 3, 3, 7, 4, 8, 5, 10. If I I need to zoom. Hold up. Zoom. 9. All right, so there's my graph. Now, this is the first one that we've seen that's not perfect. You just have to kind of do your best. Now, importantly, the line of best fit is a straight line. It does not zigzag to get the points. Its goal is to go through the nearest middle that it can. You can typically expect about half the points to be above the line and about half the points to be below the line, because again, it's trying to go right through the middle. And the last piece of information that I really need to tell you before we've pretty much done everything today is that when it comes to this line, it is guaranteed. Let's see here, where do we want to write this? I didn't really leave much room for it. All right, linear regression goes through, there we go. The linear regression guaranteed is going to go through your x bar comma y bar. And what does that bar on top mean? We learned about x bar, the mean or the average. And so basically, it's guaranteed going to go through your average x value and your average y value put into a coordinate. So that's all there for us. What if we wanted to interpolate when x equals 2.5? Again, it's at this point already a little bit annoying to be doing in your head. So we can just do second window to pull up our table, starting it at 2.5 and then going to second graph. And there it is. I got 4.95. The table is not the only way to do it. You can do it many other ways, but I think that the table is the easiest way to do it. Okay, let's skip the next one. I don't know what's going on with the brightness on this thing, but whatever. Let's go down to the last one here, okay? It's very different, so let's go to stat edit. Again, it's up to you. I like to go up to list 2, hit clear, and then press down so that it will clear out the list. 8, enter 2, enter 5, enter 2, enter 8, enter. Stat, calculate 4, store it into alpha trace, enter y1. I'm gonna go ahead and plot this. 1, 0, 2, 2, 3, 5, 4, 2, 5, 8. First thoughts, looking at this data, how does it look? Not so good. Not so good, okay? If we think about trying to make a line that goes through these data points with half above and half below, none of these ever really look all that good, okay? It looks like it's more of an X shape than a line shape. That's definitely not a very good thing. When I did my calculations, I got my A value and my B value, which was 0 and 5. but I also got my R value, which was 0. Now, in real life, you're not likely to ever see the number 0. It would probably be something like, 0.2 or 0.1. But I was able to make a question where you had it exactly a 0. This is a no correlation. These data seem to be determined by something that is not a linear correlation. If I want to look at my graph with the line, I can look at it, and again, it's not that hard to graph, but it goes straight across, really looks pretty terrible. Now this one says extrapolate when x equals 23. Now I could do this, right? The answer is going to be 5. If I plug in 23 to x, it's 0 times 23, which is 0, and then plus 5 is going to be 5. But importantly, this is useless data, right? Your R value, which is your correlation, is basically how useful is your data, and if it is 0, that means it is useless. So we could calculate that. I guess they wanted to, but it really is useless. All right, we're pretty much finished with the notes. Let's, at the bottom here, calculator reminders. I don't know if this is very readable or not. I did my best. To clear a table, stat, edit, up, clear, down. That will clear out your list in your table. We talked about that. In order to find R, you need to do second 0 to pull up the catalog, press your D, go to diagnostic on. That way you can find the R value. If you're looking to find an X value, I think the best thing to do is to press second window, which is going to do your table set, type in your X value, and then do second graph to look at the table, to then find it. Down here it says to find the line of best fit, stat, calculate for, store, alpha, trace. That's how you get that Y value into that Y1. And then this says second Y equals on zoom 9 to graph the stats and to look at those stats. Again, other little shortcuts that we've talked about. We talked about how to reset the zoom. I think we're pretty good. Let's make sure we hit all this stuff at the front on the top. I think we look pretty good. All right, that is regression. I think that's good enough for how to go through this. Make sure you're typing in carefully. Make sure you have your calculator settings all the right way, and it's not too bad.